Maximum likelihood. Under the presence of heteroscedasticity, autoregressive conditional heteroscedasticity, ARCH, effects, in the residuals of the daily returns of stock and exchange rate series, the ordinary least square estimation, OLS, is not efficient, and the estimate of covariance matrix of the parameters will be biased due to invalid t-statistics. Therefore, ARCH-type models cannot be estimated by simple techniques such as OLS. The method of maximum likelihood estimation is employed in ARCH models. For the formal exposition of the approach, each realization of the conditional variance is the joint likelihood of realization. The log likelihood function is. The parameter values are selected so that the log likelihood function is maximized using a search algorithm by computers. Model estimation with time-varying volatility, skewness, and kurtosis. As it was shown in section 2.2, when the residuals were examined for heteroscedasticity, the Young box test provided strong evidence of ARCH effects in the residual series, which suggests proceeds with modeling the returns volatility using the GARCH methodology. The model to be estimated in this study is the standard GARCH 1.1 model with constant shape parameters, and also, we impose dynamics on both shape parameters to obtain autoregressive conditional density, ARCD, models. ARCD is the approach, where dynamics imposed on shape parameters and skewness or kurtosis are derived from the time-varying shape parameters. This allows for time-varying skewness and kurtosis assuming Johnson-Su distribution for the error term in the two cases. Before presenting the estimation results obtained with both the stock return series and the exchange rate return series, the four nested models to be estimated are summarized as follows. ARCD is the approach, where dynamics imposed on shape parameters and skewness or kurtosis are derived from the time-varying shape parameters. For stock return series, mean equation. Epsilon t equals hczt, zt equals hczt j su xi t lambda t gamma t delta t. Variance equation, GARCH skewness equation. Kurtosis equation. For all stock return series, the study is going to use GARCH 1,1 model with a similar specification to that of Hansen for shape parameters, gamma t, delta t, but employs the standardized innovation zt-1 instead of non-standardized epsilon t-1 as in EKs 13 and 14. For exchange rate return series, mean equation. Epsilon t equals hczt, zt equals hczt j su xi t lambda t gamma t delta t. Variance equation, GARCH skewness equation. Kurtosis equation. For the exchange rate return series, a specification similar to that of for shape parameters, gamma t, delta t, is used with the exception that it utilizes the standardized innovation zt-1 instead of non-standardized epsilon t-1 as in EKs 17 and 18. It also considers the absolute standardized shocks for the shape parameter in 18, Galanos. So, first, we start by estimating the two standard models for the conditional variance, the R1 GARCH 1,1 model, EKs 11 and 12, for the stock return series and MA 1 GARCH 1,1 model, EKs 15 and 16, for the exchange rate return series. Second, the generalizations of both the standard GARCH and GARCH models with time-varying skewness and kurtosis, GARCs, as in EKs 11-14, for the stock return series and EKs 15-18, for the exchange rate return series are estimated. The results for the stock return series are presented in tables 3 and 4 for both the standard GARCH and GARCS models, respectively. As expected, the results indicate high and significant presence of conditional variance, since the coefficient of lagged conditional variance, B2, is high, positive, and significant. Volatility is found to be persistent, since the coefficient of lagged volatility, B1, is positive and significant, indicating that high conditional variance is followed by high conditional variance. The sum of the two estimated coefficients, B1 plus B2, in the estimation process is very close to 1, implying that large changes in stock returns tend to be followed by large changes, and small changes tend to be followed by small changes. This confirms that volatility clustering is observed in the stock returns series. For the skewness and kurtosis equations, It is found that for all stock return series, days with high conditional skewness and kurtosis are followed by days with high conditional skewness and kurtosis except at DAX30 in kurtosis case, since the coefficients for lagged skewness, C3, and for lagged kurtosis, D3, are positive and significant. In summary, there is a significant presence of conditional skewness and kurtosis for all stock return series, since at least one of the coefficients associated with the standardized shocks or squared standardized shocks to skewness and kurtosis, or to lagged skewness and kurtosis, is found to be significant. Maximum likelihood estimates of our 1 GARCH 1,1 model for stock return series. Significant at the 5% level. Maximum likelihood estimates of our 1 GARCH 1,1 model with time-varying skewness and kurtosis for stock return series. Significant at the 5% level. The results for the 5 exchange rates are presented in tables 5 and 6 for GARCH and GARCH models, respectively. As expected, the results are the same as in the case of stock return series, i.e., the results also indicate highest significant presence of conditional variance. Volatility is found to be persistent, and volatility clustering is also observed in exchange rate return series. A significant presence of conditional skewness and kurtosis for all exchange rate return series is confirmed, since at least one of the coefficients associated with the standardized shocks, either negative or positive, to skewness and kurtosis, or to lagged skewness and kurtosis, are found to be significant. Maximum likelihood estimates of MA, 1 GARCH 1,1 model for exchange rate return series. Significant at the 5% level. Significant at the 1% level. Maximum likelihood estimates of MA, 1 GARCH 1,1 model with time-varying skewness and kurtosis for exchange rate return series. Significant at the 5% level. Finally, it is worth noting that from the bottom of tables 3 to 6, the value of a KIC information criterion, AIC, decreases monotonically when moving from the simpler model, standard GARCH, to the more complicated ones, GARCH, for all return series. Therefore, for all return series analyzed, the GARCH model specification seems to be the most appropriate one according to the AIC. Note that the ARCH-LM test statistics for all return series did not exhibit additional ARCH effect. This shows that the variance equations are well specified and adequate.